I'm Amelia Santos. I'm Innuos CEO and co-founder, and it's a pleasure to have Leo here visiting us today. So behind me is the Innuos new facility that we inaugurated this year, and it's a pleasure to show you inside so you get to know more about Innuos behind the scenes. Can you please join me? So this new facility was inaugurated in March. We needed more space and to develop in terms of having additional team members and also creating a production area and a sound room that was bigger and that would have more quality standards. So please join me. So in here, the first area, we have a reception where we can show the visitors about our systems. So you can see the range of products that we have here and a bit more information on our software and our philosophy. And we can come here later. I'll just give you a short tour for the office. So this facility, we have 45 team members at the moment. About 30 of them are in this facility, and the others, we have people in our office in the UK, we have people in the US. We also have team members around Europe. So this facility here, I'll take you through and show you the office. We have about 10 different nationalities at the moment. So it's a very multicultural team, which is great fun to work with. So we have some of the awards. So over the years, we've been receiving more than 100 awards on our products internationally around the world. So we're very proud of that. Also, we received a number of sustainability awards and awards regarding of the performance of the company. I was graced with an award from the EU and also from Forbes as one of the women founders to follow in Europe, which I'm quite proud of. So we have our sound room, will be our little secret for later. So this is the office. We have a few people on holidays this week because we had a bank holiday. And so we have the IT team here that takes care of the infrastructure in the company. After we have the customer support areas, so basically they can support our customers remotely whenever they have a problem. They can enter a system and can support. Or sometimes it's queries. A lot of the time customers will ask us how to configure our systems in their network or if their network is not working, so we do that support. We really care about customer service. That's one of the core values to the company. So in here we also have our logistics and international trade team that makes sure that our goods are shipped all around the world in the best way, and that we deliver things to customers and make their jobs as easy as possible. We also have our finance team and orders team in here and projects. We do a lot of improvement projects internally, so that's also core to us. The marketing team and design, so and also our events team. You can see the calendar at the back. We do events internationally from North America, Europe, Asia. We're doing several events throughout the year, and you can see the calendar where we're planning those events. So if you continue, so this is a wide open space. We're based in Faro, in Portugal, and it's usually a very sunny area throughout the year, 300 days of sunshine, which means that we can also take advantage of that in this bright and high ceiling type of space. So if you follow me. So we have the HR team over here. So the culture of the team is something that we care about a lot. And they're also based in this premises. And now I will take a bit of time so I can get dressed, and I'll take you to our production facility. Action. So our new facility, we have a full ESD production lab where any visitor that joins us will have to get dressed and put proper protection on the feet. So the reason why we do this, if you think when you probably, everyone got already a kind of electric shock when they touch metal, and that happens because there's an electrical discharge caused by friction. So if we think of static electricity, it can build up by friction on your body, it can be from your hair, it can be in the air because cardboard, plastic can create that. So if you have static electricity in the air and it gets in contact with electronic components when you're working on them, it will damage the components. And sometimes you don't see that straight away. It might hinder the component longevity and it might stop working later on. So we take good care of that and we make sure that people dress a coat so it covers the clothes. Any friction that happens in the clothes are protected by the coat. And also any static electricity that you might develop in your body or by friction with anything, it gets discharged to the floor. So if you see this tape here, the team that works inside, they have special shoes, but for visitors we have this. And basically you need to put it in contact with your skin and all the way to the floor. So any static electricity that you might develop will go, it's grounded, you're grounded, and it will go to the floor. And then we'll see on the premises that you need to do a test and you'll only be able to enter if you're really discharging that static. So now we have here the electronics lab where we do our production. So as I mentioned to you, this is all full ESD protected area, which means that we need to be dressed, as I explained, and have the proper shoes or have covers that allows you to be grounded. And in order for the door to open, you need to test yourself, because the system will tell you whether you're actually doing correct grounding, and you will also have to be recognized by the system to have authorization to enter in the production facility. So I'm getting recognized by my face, and then I'm doing the tests, and then I'm able to go in. So this is our production lab where we assemble all our products and we also produce our electronics. We have Anderson Baldoni here, so he's responsible for the operations. He has a lot of experience in electronics from working in Foxconn in Brazil and Lenovo, and he's working on his English and Mandarin. So the way this works, the whole facility is ESD. And what does that mean? It means that even the floor is a special vinyl, it's everything grounded, and also there's restricted areas where there's even more care in terms of what material it's used. All the benches are ESD, so they'll even have resistors inside. Everything is grounded. The chairs that you can see, a lot of care put into the bins where plastic or cardboard is stored. The team will use gloves to make sure there's no contact in terms of skin or sweat. We take a lot of care in terms of production and making sure the quality is standardized. So the torque and the electronic screws are also ESD, but they are also checked frequently. So you will see in terms of another care we take is on the ionizers. So if you see the equipment on the top over there, so that actually is discharging negative ions to contract on the positive ions that are generated by the friction on cardboard, plastic, or even on the air that it gets generated. So the way it works, we have the picking facility on that side separated, where the team will pick the required components for an order. And we have different types of orders, so it could be just checking a component, it could be doing a sub-assembly, it can be doing a final product, so they are picked over there, and then they get into this circular belt because it's more efficient, it can be picked up by different team members on each bench, and also if they notice any issue with one of the components, it can quickly be returned back to the picking area where it will get inspected. So the circular belt is taking the different orders, and they will then be picked up by the different benches that you have over here. We also have team members on holidays on this side. And we keep training the team, so not everyone is able to do all types of systems. Higher-end systems like the statement, like the pulsar, they'll require more training to be able to do them, to assemble. So we will go into more detail on what each one of the team is doing at the moment. But you can see the organization of the benches is something that we also take a lot of care to make sure the quality standards are in place. We also use a special type of solder done for us where we can ensure there's less impedance in terms of the components. The whole facility, it has controlled humidity and temperature in the whole space to make sure that the solder quality is to the quality standards that we require. All the orders are done centralized on the system, and we're doing a project to move instructions from the paper also to have them on screens on each one of the benches. In here we also have a scale where we weigh the components to check for any quality issues, also to make it more efficient whenever we're doing stock counting, so we can make sure we always have the stock we believe we need, and also when we receive it. And on this side we have another bench that is focused more on rework. If there's anything that needs to be checked, we checked each stage of the production. So whenever a sub-assembly board is soldered with all the components, because we produce electronics, we design and produce our electronics here. Whenever it's finished, we do the quality checks, and on each stages of the process, we do the quality checks. So the rework that might be done here, and in here we are actually producing the PhoenixNET boards. We'll talk about that in more detail. And we also have a research and development bench over here, and another one over there for whenever we're working or designing more in terms of chassis.
Hi, I'm Nuno Vitorino. I'm the Research and Development Director for Innuos. Just showing you around one of the areas where we do our initial research and development. So in doing so, in particular because we design our own power supplies, we design our own Ethernet boards, our USB boards as well. This is the place where we build our initial prototypes. So it's a full ESD facility like the rest of the production unit. And particularly what I want to show is a bit on how we can do this. So for instance, we have quite a set of components. For instance, on this part over here, on this cabinet, we have, for instance, lots of different inductors, we have capacitors, we have different resistors and so on that we test in terms of different possibilities for them to be used on our products. So for instance, when we go through a power supply design, we actually test quite a lot of combinations of capacitors. And for each one of those, we need to make one change at a time, burn them in for 2 weeks, and then we can compare to our reference design to understand whether there are improvements or not over what we've done. So this is actually a very time-intensive effort in order to get the designs as good and sounding as good as we can. We also have one of our top-of-the-line Regal oscilloscopes where we do measurements directly from the electronics. So that's actually quite useful for doing initial testing to see how well the circuit is performing. But in the end, it's about having the testing on the sound room, having a listen and understanding a bit more in detail whether the changes that we're doing actually make sense and make good results in terms of the sound quality. But again, it's quite a time intense. So we test here different motherboards, we test different memories, we test our electronics here. So there's quite a lot of different areas that we test out extensively before they actually make it into the reference system. Well, just as an example, we have a sample here of our PhoenixNET board that we've designed ourselves here at our premises. Just to give a general idea about the principles and layout of this kind of board. So we're using industrial Ethernet connectors here. So you can see them, they're all independent, they're quite sturdy, and also they have silicon all around to protect a bit from vibration on the chassis. We use very high-end isolation transformers for each of them. They're all independent. But most importantly, the chip that we are using as a switch does not contain switching regulators. So in this area over here actually provides the 3 different voltages. So these use the ultra-low noise regulators to provide each of the independent voltages on the chip. And then, as you can see, we can use the likes of Nichicon caps here, so not the generic SMD caps that most of electronics have. We actually go for audio-grade components at this level as well. This board then gets 2 separate power supplies. So there's one power supply just for the OCXO clock that we see here, as well as a 5-volt for the rest of the circuit, which then it's further linearized by these 3 ultralinear regulators here. Also importantly, we actually do a fence around the OCXO clock, and this is to minimize any thermal contagion from the components around it. So this is quite important because the stability of the clock, it's not just about the specs, it's how you implement it. So this helps implementing the fact that we keep the clock very stable from a thermal point of view, and it doesn't get affected by the components on its surrounding. So just an example of the level of detail that we take into in designing our own products. This is an example in terms of the assembly that we do on our statement. One of the key principles is that we don't use connectors whenever we need to cable our system. So we actually solder them point to point on every component we're doing here. This actually means that some of these cables are actually soldered in place in the box already. And again, this is to avoid having the impedance mismatch in terms of, not mismatch, but in terms of differences in impedance between the components and the connectors. So everything is actually built inside here and it's soldered inside so that it's kept all intact. We don't just use separate parts and just connecting using connectors there. This ensures, because in terms of impedance, it ensures the lowest possible impedance for our systems, and this is very important in our power supplies. And just to give you an idea, everything here is hand-cut, hand-wired. They're soldered individually, and a full statement will take pretty much 2 days of work of one person to actually get it built. So there's a lot of workmanship on these systems. Here we are now starting the assembly of an Innuos Phoenix USB. So we actually go through several levels of quality control check. So when we receive our parts, we actually do the first initial quality control to check for any more evident bumps or scratches or anything that it's not quite right. But actually, even before the assembly, we actually do a complete visual inspection to ensure that everything is correct fact that all the tolerances have been accounted for and everything is setting up perfectly. So then we have obviously the components that we come here from the picking, and then the assembly will start. So again, just like the Phoenix Ethernet, the PhoenixNET, we have the Phoenix USB board here that we have designed with the OCXO clock and with the same kind of industrial connectors. Again, same approach in terms of having independent voltages into the chip without switching regulators, and they're all provided by ultra-low noise regulators. So this is an example of the soldering in place from one of the ARC6 modules on the statement. Just to give you a sense, there's actually over 200 points of solder into a statement when it's being produced. So that actually accounts for a lot of time and workmanship, but we want to ensure that we get the best results out of this. We can also see here, if you look in terms of the inside, the AVC platform that we have on our systems. So that is a combination of Panzerholz with a specially formulated gel on top, where the boards will be mounted on top of that. So this will help both with high frequency and medium frequency vibrations on the system that affects, in this case, particularly the regulators, the rectifier board. So continuing on the Phoenix USB that we've seen just a little while ago, so this now goes to the next step where we're checking, doing the final QC check after the assembly is completed. So in this time, so we're following our testing sheets here, and it will go, so we have a technician here who will go through every screw, make sure everything is properly tightened at the right torque, and then he'll actually sign each of the screws that actually have been checked and check marked. So everything then is properly checked to ensure that particularly during transport nothing comes out and it stays properly tightened. Once that's done, that's closed, and then it goes forward the electrical testing.
So this is our picking area. It's also full ESD, so the same type of flooring, and all equipment is ESD. So as you can see, the bins are ESD, the boxes that we have here are ESD. We've done a project internally where we simplify the process of the components from the time they're checked for quality at the entry, we'll go there later, until they are assembled in the production area. They're only touched once, so they're just touched when we're checking them for quality. They go inside the ESD box, they're stored away in the warehouse, especially if it's something bigger like a chassis, and then they're only opened again on the production area. And the objective of doing this is from an efficiency point of view, but is also from a quality perspective, so we don't damage the components touching them several times. So all of these boxes are ESD as well. So we have the chassis over here on this area. We have several sub-assemblies already ready. So the bigger areas are in here. I can show you things like, for example, the fascia for for the pulsar, where you can see this is a big block. It was all machined, so it's a 5x CNC machine that creates this shape, which is quite hard to achieve, and everything is encapsulated. Everything is machined into this block, including where the button goes in the case of the pulsar. So I'll store this away. Another example of another component we have. So another example on the pulsar is the top plate is also very heavy and all excavated and CNC'd. Like the screws will go in. There's a lot of detail in terms of the design of the components. I'll ask the team then to put it correctly. So here we have a Kanban area where especially the smaller components and the sub-assemblies are stored. It allows us, it allows to be supplied from the back, and it allows us to have a visual identification whether we're running out of stock of something, so it can be replenished. In terms of how this works on the picking, so we receive an order in the system, and the order in the system can be, it's automatically generated based on the level of stock that we predetermine that we want to have on sub-assemblies, on final products, because we keep stock out of that. And the system will check in terms of stock level and will generate manufacturing orders that go into the planning that we need to fulfill. So all these different components then will be listed and will have to be introduced into the order and checked, and will go into these boxes on the cart that will go into what we call the sushi boxes, and they are picked from all these components, and then they go into the belt and go into the production area. Each one of them will have a quality check that accompanies the product from start to finish. So we have all the checklists that we will do that will also go into the system, so it's easier to monitor. We have tracking from all the components that we have inside of the system. We check them in, and we can do traceability completely inside the system for a serial number. In this area over here, we have the installation of software, and we have the finally inspection in terms of quality, testing the usage of the system, and we have a burn-in. Nuno can explain a bit better in terms of the software installation part.
This is the software installation area. So we've actually developed our own system to install the software into our hard drives and SSDs. We developed the entire software for this in order not only to be able to clone and install the system, but also to check it from one point to the other. So it does several checks on the software level to ensure everything's all right with the drive. We also pre-configure automatically. So we have images already stored in our central NAS that are pre-produced by our DevOps team, and those so it accesses them directly so that they can be updated from a remote area. So whenever we have new versions and we need to install them here, the DevOps team will update the images on the central repository, and this system will pick them up automatically and can install them. So for production, they don't have to worry about what images, what versions are around. They can simply insert hard drives or SSDs or the SATA DOMs into the different areas, and the system will do that automatically. Once we have that, we go for these stations where we individually test each one of the systems that we produce. So they all here, so systems like the statement will stay in burn-in for about 3 days. So to ensure that everything is working correctly, and they get checked in terms of the software. We have this kind of a generic speaker where we test out, for instance, on the Pulse Minis and the Zen Minis, we can test out all the outputs, so via USB, optical, coaxial, and analog. and that way we can ensure that all the outputs are working correctly when it leaves the factory. So this is something that we do. It's really not something we just do on high-end systems. Every system goes through this in order to make sure that whatever leaves this, it leaves from here working correctly.
So this is the inspection room where we receive all our components, and we do the quality checks and the registration on the system for the different parts to make sure that each part gets checked and registered. We also have another process that we implement, so the boxes are here ready, ESD, to go to the production area. We also have another process which is rush lot. So basically when we receive the components on a lot, we will take a sample, we put it on a rush lot, it gets into the production area so we can check for quality, and we do that by doing a full assembly of a subassembly and a final product, so we can make sure that it not only looks visually correct and with all the measures, but also that when we assemble that it works perfectly. So we can decide whether we need to give any feedback on the lot to the supplier or not, because we do keep stock of parts internally and we don't want to discover that there's some problem with the lot a few months later. So that's why we do it straight away. This area is also half, it's ESD, not as restricted as the other one, because we'll get some cardboard over here, but we go to the details, like for example, you can come with a pallet over here, and this is ESD, so there's this type of details. So this is the final part in terms of the journey of a product. We hold stock of our final products, so in this way we can have shorter lead times for our customers. So we usually have 2 days lead time for majority of our products. Exception, the statement might take a few more days, but usually is up to 5 days. They come from the production lab, as you saw them. They come on carts like this, on boxes. They are stored in here, but before they are stored, we do a final inspection. So Peter here will do an inspection. So basically, he will have the checklists that he will finish. When we move all of this to system, it will be done also on the system. So you will check. This is a Pulse Mini, for example. You will check all elements in terms of the Pulse Mini to make sure, in terms of visually, no loose parts, all the screws outside. So that's the visual check that he will also do. He will then clean the system and everything, and we'll put it in a bag to go on the final packaging. As an example, so we have different types of packaging. So for the Zen Mini or the Zen, so the Zen series, we use a type of packaging obviously done for us. So it uses EPS, it has for the cables and all of that. And now we are trying to make it even more sustainable that we have here. So we designed together with a packaging company a solution that it's full cardboard, so it's even more sustainable, where everything was designed in a way that still protects the product for transport, because we ship products to over 47 countries, so we want to make sure that they arrive safely and in perfect conditions. So we designed this to be able to accommodate the products. After the packaging is done at the end, and an order, we store, after the products are stored here, when an order comes from one of our dealers, we'll then pick the system and we will package it, and then we'll check in terms of weight to make sure that each product that we ship has precisely the expected weight. And why do we do that? So we are now introducing all these amounts that you see here. We're in the process of introducing them all into the system. So automatically it will tell us when we put the product here if there's anything missing. It's a highly sensitive scale that will say whether it's a cable missing, whether the cable is the wrong one, not a US, for example, and it's a Euro cable. The same thing with quick start guides. So we'll be able to detect whether the product is in the conditions that we determine with the components that we expect. And then we will go and work with the different logistics partners to create the order, the shipping order. And then they will go, so usually we don't do a lot of shippings on Fridays because it's a next day delivery in a lot of countries, and especially in Europe. And we want to make sure that on Mondays stores tend to be closed, so we don't do that. We put them in the respective cart of the logistic operator that we work. We work with several, usually Express, where we put all the boxes, and then when the logistic operator comes, we just take the card and move it outside. This is our warehouse where we keep the stock of packaging, bigger items like the chassis. Packaging is here, so because it's cardboard and some EBS, we never take it inside the production area. It goes straight to the packaging area. The other thing, as I mentioned, we also have here the ESD boxes that are ready, coming from when we receive the chassis, ready to go inside to the production area. So this is a space where we keep the more bulky components.
So this is our technical service area. This is a restricted area from the rest of the production areas, because on this place we have we have customer systems, so we want to make sure that privacy and security are above everything here. It also helps in terms of customs management, so it allows us to show there's a safe customs area that is isolated from the company, and this allows systems to come for service from different areas of the world to actually come in faster for us. So in this area we actually have so this block over here where we do we have a backup station, an automated backup station. This is similar to what we have in production for cloning, but it's actually quite a lot more involving. So first thing is that it actually does a number of diagnostics automatically, but also the fact that we can back up systems and hard drives directly, and the system will detect, for instance, whether the customer is using Rune or if it's using Innuos, if it has files, whatever settings they have. And for instance, if they're upgrading from a 1 terabyte to a 2 terabyte system, all we need to do is just pop in the disks in here and just say we want to upgrade, and the system will do the rest. So this is actually quite important to avoid any kind of human error. Whenever we're managing data from our customers, it's something that it's really, really important for us, and we take it very, very seriously. So we wanted to make sure that we have a process that it's very error-free, that it's consistent, and can actually be fully automated from this point on. So on this area here, we test out systems, and we test for the different and diagnose for any different kinds of areas, and we also have the bench over there where we can do upgrades on our systems. Also relevant, if you want to come around this area over here, is our video station. So we have a video station with 2 independent cameras that allows us to produce content for our service centers around the world. So here we can provide examples in video on how to replace common parts or how to diagnose certain problems. We then have a service portal that is available for our service centers in order for them to be able to log in and get those contents for instructions on how they can manage the system. So this will provide a wealth of content for them in order to help them diagnose any issues globally. So rather than, depending on phone calls or video, specific live video sessions, we can provide that content to them via the service portal. So this is something that we're still implementing at this stage, but it's ready now, and it's something that we'll start rolling out to our service centers all around the world. Let's talk a little bit about the software now, because sometimes there is a tendency to focus a lot on the hardware side of things, and whereas the software actually is a very, very large part of the development of our products. So we currently have a team of 7 software developers. That includes our QA and DevOps teams, so that we can actually produce the software, and we can give you a bit of an overview of what it takes to develop the software for something like an Innuos music server. So we use a very structured approach on our systems. We use all our software developers are Agile certified. So we use a Scrum methodology for this, and this means that we start by defining what we call the epics, the major features of the product. For this, we actually take into account what we have on our feedback zone. So the feedback zone is a public portal where our customers can register and they can propose features for our products. So we actually, and once they propose those features, they can vote for them. And the higher voting, actually, the more is the chances that actually they get prioritized and get into the next updates. So right now, when we come here to the feedback zone, we can see that we have in progress what we are already testing at the moment. So these are features that we are already testing, and the ones that we are implementing at this stage. So we also provide, and also obviously the ones that are live. So this way we can provide a glimpse of the roadmap to our customers to say, okay, what is Innuos working on in terms of software for the more immediate, the short term, let's say. So the next version, what will come out. So we're testing now, for instance, things like having the multiple shared SMB folders, or reading music files from USB sticks and so on. Whereas we are currently implementing, for instance, the Deezer integration, which is going through certification now, for example. So this portal will give you an idea, and also then we can come to all the feature requests, and if we order them here, let's say by top, we can see the features that have been mostly voted. And on each of these features, it works a little bit like a discussion forum. So when people propose a feature, we actually need to approve it first. So that gets checked by either myself or our product specialist, which then we can start commenting. So we can use this area not just to just take the request and that's it. We can use it as a discussion point. We can use it to say, but you're proposing things this way, why not, shall we do, or what about if we do this other way? Would you be happy with that as well? So we can actually go on a discussion forum here as well with our customers to try, and sometimes we actually use it the other way around. We say, look, what do you think if we do things this way and this way? What's your opinion on this? So we can get that feedback as well from our customers. So if we go back now to our structure. So once we pick up one of the major areas, we start dividing it into different stories, so into different areas that we implement. So giving here the example of tag management, we have here the division. So we're going to tag detail for albums, navigate the tag detail for artists, multi-selection of tags, and so on. So we break this down, and we work interactively with the team first to define the user experience, and then once we're happy, and that involves doing mock-ups of the user interface and discussing the overall behavior of how the feature should work, and then when we're happy with that, that goes to the technical team to do the technical refinement, and that the team will then pick up on the kind of behavior that we've discussed, and will basically do a technical design of what they need to implement. Once we have that technical design, the items go into our backlog. and on our backlog, we can then structure there and basically prioritize based on importance. So we can have different items here, we can put them more on top, more on the bottom, and we can decide for each sprint what we're going to implement next. So whenever we go into the next sprint, and we have 3-week sprints, when we are doing our implementation, we define a certain objective. Oh, we are going to do tags for albums, for artists, and the multi-selection of tags, for instance. And that then becomes our active sprint. And on that, this means we have a complete control of what the team is doing. So this is a full Innuos team. This is not outsourced in any way. So they're all Innuos employees that work 100% for us. And with this kind of board, we get an idea what's being done now, what's in progress, what's ready to test for QA, what QA is testing at the moment, and what is done. So we see this progress going through as time goes by over the sprint. We then have things like reports where we can see how the features are being implemented, and we can have a very good idea about the performance of the team and if we're doing well and if we're getting things done on time. So it's a very structured approach to ensure that we have the software first, that we're implementing what we wanted to do, we are implementing the right user experience, but also that we do it with quality, that we do it well done, stabilizing and providing as little bugs as possible. So there's actually several steps where we do quality assurance on our development. So one is actually during the sprint itself, but then once we have several sprints, we group them into a release. So normally we have two or three sprints in order to cover for a release. And in that sense, we normally are covering 3 releases as we go in a rolling way. So we have a release that's being developed and tested. So actually, a release that's being tested, a release, the next release that we're under development, and then we have the release after that we're actually planning now the user experience and the stories and making sure we understand what the user experience and what features we're going to implement. So at this stage, or as of this date, we are now testing release 2.5.5. We're starting the development of version 2.6, and we're now starting to plan version 2.6.5. So one of the things I wanted to show here as well is how much time is actually dedicated into release testing and regression testing. So we have a first stage where we test all the software that has been newly developed. So all the features that are new to this release, we're going to test them all over again to make sure that they're working correctly, there's no bugs, and everything is being done as we agreed to. Then we'll have a further stage of regression testing to ensure that the whole platform, there's nothing that has broke based on what we've implemented as well. So we actually take quite a lot of work and quite a lot of time to ensure that the software comes as bug-free as possible. Even so, given all the circumstances, all the different variables, different file formats, different DACs, different network situations of people at home, even so, it's sometimes impossible, and we do find issues after that where we can normally, when we detect that, we can generate hotfixes very quickly because the team is on top of things. We prioritize those bug fixes, and we can make releases very quickly. In fact, it's one of the areas we've automated quite a lot. So we have a full automation to create a system release. Whenever this is all managed by a Git repository, and we have fully automated based on a flag that that we put on a certain type of or area of the code on a certain repository to say, okay, this is the tag for version, let's say 2.6. Then basically we have the full automation that produces all the update packages, and that's ready for all the systems to go. We then go after this, and during the release testing and regression testing, we also have beta testers that test the software. So we have an automated area where we can take selected beta testers, we can enable that specifically for them, and all they need to do is really just update the software normally. So for those specific systems, they'll receive a notification that there's a new beta available, and they'll be able to update it accordingly, and they can provide that feedback to us if they find anything that it's not working correctly. So again, just to give a very small idea of how much effort actually it goes into developing the software, both from the user interface point of view and the backlog. I'd like also to mention that we do the full system, the full software of the system. So that includes the Linux kernel, so that's compiled here, it's customized and compiled here. The base of the system is prepared, so this is based on Linux. That Linux base is actually prepared by us as well to include a minimum of things to work. So we don't want to include software or applications or services that are not used for the music server in any way. This makes the platform as light as possible and fully dedicated its resources to the audio part. This is one of the main advantages of Linux sometimes versus Windows type platforms, where there's quite a lot of software running at the same time there. With Linux, we can select very, very tightly what we want to run, and it makes it very easy to update from version to version. So we can update the entire, not only our application, but the entire operating system using our updates. So that's also something that is an advantage for the platform we do. When we go here into the infrastructure, we can have just a sense of how many systems we have for quality. So there's quite a lot of both virtual machines and physical machines that we use in order to check at several levels. So from the development level, QA, pre-production, and production. So those are all 4 levels where we do constantly testing of the different versions to ensure that we can try and find and make it as stable as possible for a system. So when we go to our MY-Innuos here, you can see there's actually quite a lot of systems there that we use to test on our premises here. So hopefully this gives you a bit of an idea of what is involved in producing the software, and it's actually something that we enjoy quite a lot because it allows the team to be all together and everybody to be involved. And we always try to get software developers who are passionate about music, because we don't want them to just implement the features. We want them to make sure that they're proud of the work they're doing, that they actually enjoy and they use it on their day-to-day. That's why each one of them has one machine just for them in order to use it at home.
I'm Amelia Santos. I'm CEO and co-founder of Innuos. Before we founded the company, we both had international corporate careers. So I'm a computer science engineer. Started my career at SAP. I was doing programming, then I was doing consulting for companies on the customer relationship management software, moved into business development, then into sales. Then I joined SAP in Germany to work for the board on strategy for customers. And then I decided at that point that I needed more knowledge around the strategy area, so I decided to do an MBA at INSEAD. So I studied in Singapore and then in France, doing an internship in Switzerland. After that, I moved to London, where I was working for Tesco, so doing efficiency and strategy projects in convenience stores, in non-food, in online. And then I moved to the leadership team on the online channel for non-food. And it was sometime at that point when we were in London that Nuno decided to create a system for us at home, because we loved listening to music, and we also had the passion in terms of computer science, so we developed that so we could enjoy music and enjoy music in digital format on our hi-fi. And then,
I mean, I can pick it up a little bit from there. So I have a very similar progression from Amelia. So we were actually colleagues in university, and we both did our computer science degree there. Although in my case, so we both worked at SAP, but then I went to the UK, where I work at Deloitte as a senior manager and responsible for enterprise applications there for SAP. So at some point in time, so this was always been a bit of a hobby to me, and I was using a bit of the computer knowledge that I had at the time. It was a bit of the dawn. This was about 2009, the kind of dawn of computer audio, and I started doing a very small system using, third-party software, third-party components, but actually pre-configuring everything so that it made it very easy to use. And at the time, there wasn't a lot of, there wasn't a lot of apps and iPhones and all that as there is now, but managed to get a system working. And when people would see it, say, "Oh, this is actually quite nice. Where can I buy this?" Like, well, I'm not aware that you can actually buy it. You can do it, or you can ask a custom installer to do it, but it's not something that is generally available. But long story short, I decided then to start building up a few of these kind of off-the-shelf systems. And to my actual surprise at the time, it started selling really well, to the point to say, look, I can't keep up with a full-time job and doing this. So we started to realize that there was a real opportunity around this area. And I think that comes down when that was the beginning when we start seeing the kind of design philosophy we wanted to do for the brand. Because what was attracting to people was the fact that the system was very easy to use, and it was ready, and it was plug and play. And we got feedback after feedback after feedback that, I've plugged it in, I've turned it on, I pop in a CD, click a button, and it starts play right away. It gives me such a nice experience. And now, I'm buying it for myself, but I'm just going to buy another unit for my dad as well, because it's so easy to use. I think it's going to be very comfortable in using it as well. So that was one of the things that are part now of our ethos, is to make sure that the user experience, that it's a very easy to use system, that you can turn it on and it just works. And that's really a big objective for us, to make sure that it's very easy to use. Then we started doing more the research and development in terms of how can we actually improve the sound quality on digital systems. And that's where we started at the time working with Dr. Sean Jacobs and developed the initial designs for the linear power supplies. And then we developed more. We started to develop more areas as we figure out, okay, power supplies are important, but they're not the only thing. So we started developing the USB boards, the Ethernet boards, also a lot of the software as well. So this came up to around 2016 when we launched our Mark IIs, which are the first time we launched a system with our own software and complete hardware that we have now. And that was really the jump board, I guess, from that point on, because the acceptance on the market was fantastic. We had great partners as well that helped us launch the brand. So I remember clearly that CAF was using to launch their LS50 wireless speakers, and they used a Zenith to show it. And for us, as a very young company at the time, it was great to see a name like CAF actually bringing us front and forward forward. But indeed, they saw one of the things that many of our customers now see on our systems is that it just makes everything sound better for them. It really made their product shine. And I think from there on, it's been...
all the awards that humble us that we're getting from the press, all the different awards we've got so far, and all the partners that use our products. So we have partners all over the world, very well-known brands. I could name quite a few, and I wouldn't be doing justice to all of them, but I don't know, from Rockport now more recently to Bowers & Wilkins to Cord Electronics to Cord Cables. So I wouldn't be doing justice to everyone that is currently using our systems, and that we also use their products in our sound room on our shows. Whenever we do a show, we try very carefully to do a setup that will be able to demonstrate the sound, and it's unique. We take great care on selecting the systems for shows and creating that environment that people can experience, can do ABs, understand the difference between our own products and the difference that the digital source can make to their system. And we keep stretching in terms of technology to take the digital audio further and further. But we also want to make sure that we trickle down that technology and that we make it available for more people to be able to test it. And that's why we have more entry-level products using that trickle-down technology so they can access that. So the company evolved. We have 45 people now. We are in more than 47 markets. We have these news facilities that we inaugurated this year. It's 1,000 square meters. We needed more, and we'll keep increasing in terms of space. And we'll keep stretching the boundaries and launching new products, addressing new markets, and making sure that we provide the support and keep doing the quality that we feel it's required to provide good products and good service to our customers so they can enjoy music. The other side of things that are quite important to us is also in terms of social responsibility. So a few years back, when we felt we had achieved quite a lot of success, we wanted to give back to society. So we decided to create a fund focusing on education, where we support through scholarships, through allowing our team also to continuing studying, to also helping other institutions such as Teach for Portugal, for example, or Schoola that also teaches music, or Teach for Portugal that supports mentors in schools from underprivileged kids to progress further and to see themselves developing further in life and continuing study. So we support those institutions so they can help out in society. And whenever we can, even as a team building exercise that we do, we gather the team a few times. And we also do those type of activities because we feel if we're successful, we need to give back to society, and that's something quite important for us.
Hello everyone, my name is Yaohan. Actually, I joined the company about a year ago, and I'm in charge of Asia Pacific and Middle East and Africa as a home market for us. And for the coming months, we will be focusing on the Asia Pacific region, and I'll be developing a lot of new markets. So our focus will be first, obviously commercially developing these markets, finding local partners to work with us, and secondly, I think the most important thing is the localization. So we will work a lot with the local streaming services partners, and also to translate and to develop all the content and knowledge in the local language, for example, Chinese and Korean and so on and so forth. So these are the two main areas we're going to focus on. And to our Chinese-speaking friends, I'll say something. 大家好，我叫耀涵，然后加入公司大概有1年，然后接下来的一段时间，我会花很多的力气在亚洲，还有中东啊其他地方，然后帮助开拓 Innuos 这个品牌，然后帮助大家了解、理解更多我们的产品的哲学，然后为什么要选择它，有什么好处，诸如此类。谢谢大家。